Woohoo! We are live. This is Math 40, Elementary Algebra, and we are in section 1.3, and we're talking about real numbers. Woohoo! And up until now, we've been talking about the different sets that come before the set of real numbers. And so what I'd like to do is take this Venn diagram, which is very lovely with all the beautiful colors, and talk about how all the different sets are related. And hopefully you did notice that when we were going through the different sets of numbers, and these are, I should probably list them. Let's see. Ooh. Let's see if I can list them right here. We've got the natural numbers. I'm going to use the hashtag to save a little space. W, sorry about that, for the whole numbers. Then we've got Z, which was kind of weird, but possibly coming from the German word Zahlen, meaning, oh my gosh, I've completely forgot what it means. It means something important in math. And this is the integers. And then we got into Q, which was the set of rational numbers. And Q stands for quotient, basically dividing. And then the other set we were talking about was, now this is tricksy because it doesn't always have a letter. Some books call it H, some books call it something else. I was taught there is no letter, don't even try. So the irrationals. And then all of a sudden, we're up here at the set of real numbers. Yay! And so what is the set of real numbers? And for our class, the set of real numbers is all the numbers. And I'm going to write so far. Why do I mean so far? Well, because there are other numbers. Because there are real numbers, there are also imaginary numbers, which are kind of cool, but we don't study those in elementary algebra. At our school, we study them in intermediate algebra, but you can always go looking around on the interwebs and find more information if you're interested in the idea of something, a number that was imaginary. It's pretty cool, actually. But we're going to stick with the real numbers. And by real numbers, I mean, we're going to take the natural numbers, which was the smallest set. This is this, I don't know if it's obvious from in the video, it's kind of pink compared to the orange. So the natural numbers are the smallest set. They sit inside of the whole numbers. Remember that the whole numbers, the big thing they brought in was 0, and this was massive. And then after the whole numbers, the next set that sits around them, like the white of an egg around the yolk, except it's included, everything's included. So if you go to, say, the yellow set, which is going to be the integers, ooh, that Z is looking a little, there we go, 1. The integers include the whole numbers, include the natural numbers. They're nested, they're inside. So if you choose the integers, you get both of these sets for free. It's pretty awesome, like the best Ginsu knife offer ever. Now the integers took the whole numbers and they're like, hold my drink. And they said, why don't we bring in some negative numbers, because negative numbers are pretty cool. And then the rational numbers came in and they're like, hold my drink. We're going to bring in things like 1/2 or -3/17. So we started out with the natural numbers, 1, 2, 3, 4, 5, 6, etc. Add in 0, get the whole numbers. Add in some negative numbers, but negative whole numbers. We get the integers. Then we get the rational numbers by adding in the fractions. And then what we do is over here in its own little bubble, we put the irrational numbers. Now, these are the numbers like pi or the square root of 2. I should have written a bigger bubble, sorry. These are numbers that are not, you can't write them as fractions. They're just written as decimals, or we frequently have a symbolic way to refer to them, because since they have a never-ending decimal, the way we write out the decimal, it would be impossible to just write out all the digits. So usually we have either an approximation or like a symbol. And then the whole set, this blue set here, this is all of them. So this is like the Brady Bunch of number sets, brought together these two different families that had nothing together, and they bring them together, and then we see what sort of hijinks we come up with. And there are some serious hijinks, I got to tell you, because these two sets don't like each other very much. But more on that later. The blue set is the set of real numbers, and it is the big set for us. And for this whole class, everything we do will be using the real numbers. So the first thing we want to do is be able to be, I'm hoping you can all be comfortable with what kind of numbers you're dealing with, because that will come up. This is part of the vocabulary of math. And so I've picked out a bunch of different numbers, and we're going to go through and see if we can classify them. So, and by classify, I mean determine which set they're in, rather than try to make them more classy, because numbers, of course, are always classy. They're awesome. Okay, first thing we got to identify, this is 1/10. 1/10 is a decimal. And I should have written this first, and it's terminating, it stops. Which means it qualifies as a rational number. Is it a natural number, like 1, 2, 3? No. Is it a whole number, 1, 2, 3, and 0? No. Is it an integer, positive and negative whole numbers? No. It is a rational number. So wherever it first identifies, then we're going to move to the right, and we're going to say, okay, remember rational and irrational? These are like the Brady Bunch. They don't like each other. And then, but all the numbers are real. So in fact, if you wanted to totally cheat on this, I don't know that it's cheating. They're all going to be real. So you could circle real for all of them. So for 0.1, it counts as a rational number, but also a real number. Okay, how about the number 45? So the number 45 is whole. It's not a decimal. It is a decimal representation, but there are no digits, let me try again. There are no non-zero digits to the right of the decimal point. Here's the problem, both as a math teacher, but also as a human. Humans have a certain vocabulary. Math teachers have a certain vocabulary, and sometimes they don't get along. So 45 is a decimal. It does count as a fraction, but it is also a natural number. It's a counting number. I can have 45 saber-tooth tigers. So this one counts as a natural number. Once you qualify here, you qualify for all of them with one exception. Remember, be really careful. Irrational is its own group. It's its own, it sits over here in its own bubble. Okay, so it's not talking to anyone right now. It will be. Just wait. -2. Now, -2 sounds like a counting number, but it's negative. So since it is negative, it's not a natural number. It's not a whole number. Is it an integer? And the answer is yes. It's negative, and it is, well, it is whole, as in it's not in pieces. So it's an integer. Now, once you qualify here, you kind of can go all the way to the right. So if it's an integer, it's also a rational number, because, right, if you're an integer, you're inside the set of rational numbers as well. And not irrational, that's something special, and then real. Okay, now, 2 different examples, and one of them, oh, let me bring in, Godzilla's here to help us focus. Oh no. Oh, this is no good. What happened? What happened? I'm afraid my camera had a slight hiccup. I know a lot of people have trouble sometimes when they're in the middle of math and they start to panic. I think my camera just started panicking because it's like, oh no, it's math. And you said it was tricky. And I said, yes, this is a little tricksy. However, the goal is not to trick you. The goal is to check that you're paying really close attention. So let's pay really close attention. -13/4. That looks like a fraction to me. If that's a fraction, then that sits in the rational numbers. And then, of course, also real, not irrational. Again, a separate thing entirely. So then my tendency would be to say, wait a minute, this is a fraction. Oh, easy peasy, this is rational. And I'd say, oh no, oh no. Look carefully. Did you notice something special about 12/4? Oh, sneaky, sneaky math teacher. 12/4 is really 3/1, which is 3. 12 divided by 4 is 3. That is a natural number. Actually, I probably shouldn't do that. That means factorial. I was exaggerating, but here, I don't want to confuse anyone. So if you were watching the video, you got to see it. Okay, let's look over there. It must be a pterodactyl or something. Okay, so this is actually a natural number. So even though it is written like a fraction, it actually qualifies as a natural number because you can reduce it. Be really careful about those. If you're natural, then you're also whole. You're also an integer. You're also rational. Skip over the irrational and go to real. Okay? So they're all real. And in fact, on this page, you notice all the ones that I gave you are all rational, in fact. Okay, so I guess that tells us what's going to happen on the second page, huh? Woohoo. Only if I can get there. Ta-da! There we go, second page. Okay, so next up is what we generally refer to as a mixed number. This one's this one could give someone nightmares. -6 7/8. This is a mixed number by which we mean there's this 6, which is a whole number, and 7/8, which qualifies as a rational number. So we got a whole number and a fraction stuck together. So a mixed number means that we're in rational land unless this reduces to something whole. Does it reduce? No, 7/8 is not a full whole. So we're going to have to just say this is rational. And again, it's real because all numbers we're going to work with are real in this class. Okay, I wrote this 2 ways. This is the spelling. I know a lot of people assume pie is spelled P-I-E, like the food. I don't know if the ancient Greeks knew of pie. I'm going to guess they did, because what I know of Greek food suggests that they would. However, that's not the spelling. It's P-I is how we spell it. Or it's this little symbol for pi. This is, ding, 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 ding. This is an irrational number. Pi is 3.14 la 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 la, and it keeps going. It's non-terminating. You got to take my word on it. If you go further in math, you end up proving that pi is non-terminating and non-repeating. And if anyone's really interested, I can probably scrape the back of my memory banks and find that proof for you if you're curious. Now, even though it's irrational, it still qualifies as real. Again, all the numbers we're going to work with in this class will all be real. So real is the easy one. You just boom, 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 boom. Okay, radical 2 or square root of 2. Now for this one, it may be helpful to pull out a calculator and just take a look at what's going on. So let's see, where's my square root? Second square root of 2. Close my parenthesis. Oh, sorry. Get out of the light, Carol Ann. There we go. And you see, it says 1.414213562. That's looking pretty hopeless. I don't see any repeating. It seems like it keeps going. The problem is the calculator doesn't tell you, but I can tell you that if you have a square root that isn't nice, then it's irrational. And I know nice is not a mathematical term, but basically if the square root doesn't reduce, then it's an irrational number. It's pretty much a guarantee. Okay, again, tricksy math teachers. You got to be careful about them. Radical 9. You see the radical or the square root, you think, oh, that's irrational. But wait. Radical 9, what's the square root of 9? You got it. 3. That means it qualifies as a natural number. Once it's a natural number, it's also a whole number, an integer, and a rational number. Woohoo! So even though it has a square root, that form makes it look like an irrational number, but it's actually a rational number. It's a natural number. You can totally have 3 saber-tooth tigers. I mean, not right now, but you could have at one time. So 0, dun dun dun. 0 wants to be a natural number, but the natural numbers are actually the set of numbers that people first started using, which count for the counting on fingers. One way that I think of it, and this is going to sound kind of goofy, but the 0 kind of looks like a whole. So that's how I remember it's the whole number. Then it also qualifies as an integer and a rational number. Skip over irrational, go right to real. Woohoo. Okay, so that's it for real numbers. We're going to continue in the next video. We're going to be working with graphing. Yay! So make sure for that video you have your ruler ready. Lots of colored pencils. I'll see you then. Woohoo. Math on. Okay.